In our previous video, we have already discussed that how to download the GNU ARM toolchains and how to edit the environment for. आज हम लोग बात करेंगे कि अंडरस्टैंडिंग द सी कंपाइलेशन प्रोसेस टारगेट विदाउट आईडी। तो इसके बारे में हम लोग आज डिटेल्स में डिस्कस करेंगे। चलिए, तो सबसे पहले बात करते हैं कि हम लोग कॉस्ट कंपाइलेशन टूल भी क्या होता है वो भी देखेंगे। तो व्हाट इज कंपाइलेशन, कंपाइलेशन क्या होता है उसके बारे में थोड़ा सा बात कर लेते हैं। तो कंपाइलेशन बोल रहा है द प्रोसेस ऑफ कन्वर्टिंग ह्यूमन रीडेबल सी कोड इनटू मशीन रीडेबल बाइनरी कोड। तो सी कोड क्या है, मशीन मतलब ह्यूमन के लिए इजी होता है अंडरस्टैंडिंग पर्पस एंड राइटिंग पर्पस। जो ह्यूमन रीडेबिलिटी प्रोवाइड करता है सी लैंग्वेज, but C directly cannot access or understand by the machine. So that's why we have to convert into readable binary format so that our target can also understand and execute whatever I have written in our C code, that can be understood by the targets also. So that's why the compiler helps. So our host या PC जो है that converts to C to binary, but there are multiple intermediate state. Through these intermediate states it converts from C codes to binary codes. But in generally whenever we work in our kill or any id, stmcube id, that's we can't see the intermediate states. We only see the hex or binary or elf file. So today we will learn what are the intermediate state and what data content in this intermediate file and how sequentially it converts from C to binary file. Okay, so essential for embedded systems such as ARM Cortex M4 हम लोग यहाँ पे जनरली ARM Cortex के बारे में लर्न करेंगे, अंडरस्टैंड करेंगे। आउटपुट दैट मैटर्स, meshing code and final flash image. So which output actually we want to produce, meshing code and final flash image we want to understand. So एक ओवरव्यू देख लेते हैं। Let's see the overview. The compilation workflow has four core stages. So there are four main stages which passing through this compilation process. The first stage is the pre-processing stage, and second the compilation, and third is assembling, and fourth is linking. After that, through the object copy we'll get the binary file. So this the optional generally, that's why we in our general workflow we skip this process and we directly try to get the elf or binary file. So if we want to see the compilation process in through the image, that the first is the .c file. Okay, then through that is the preprocessor. So through this preprocessor, it is processing this C file and converted it is I file. So processor processing the C file, then it's convert into .i file. After that, the compiler came into the picture, and compiler take this I file, okay, and compile it, and then it's produced .s file, जिसमें क्या रहता है, assembly रहता है. Okay, and assembler came in this here to process this assembly file, and that will produce .o file. Okay, the .o file produced by compiling the .s file through the assembler. Okay, and next there are multiple extended library, and our .o file Also, these two files combinedly linking by the linker, and that will produce the uh, ELF file. That will produce ELF file to the linker by linking this multiple .o file and standard library, and then it's produced the ELF file. After that, the tool copy tools come into the picture, and they take the ELF file, and uh, there is also the linker script also came into the picture, and actually in linker script also come, and it's produced the .elf file. Okay, so this part we'll see in broader picture that give clear. And elf file through the object copy tool, it's produced the .hex or binary file. That is the main executable file for us. So here what is, you can see clearly that there are multiple object file, and that is called relocatable. Why it is called relocatable, we also understand it is why it is called a relocatable object file. For our source file is basically the C file. So here linker takes this O file, and there are others standard library, and also the linker script is basically present the hardware information, the RAM, ROM, memory information, and the read writable information also present in this linker script file. And we will see how to create linker script, and at that time it will be more clear to you. So that linking stage produce the .elf file. Okay, so this .elf file basically used for debugging purpose. We can, when we try to debug our code, then that's file actually uploaded into our controller, and it's uh, give the details debugging information for our uh, code debugging. So now this ELF file take by the object tools. This object tools then produce the binary or also hex file also produced. If you want to produce the hex file, so that binary file actually the pure binary executable file. So today we'll learn step by step. So first step is what? Preparing from input file is our sorry, input file is our main.c, and the output file will be sorry, main.i file. So we'll take our main.c file and we'll convert it into uh, .i file. So first what you have to do, uh, go to your folder, then prepare a folder, whatever folder or uh, anything you want to execute. Suppose I have created a folder in our D drive that without IDE test. Okay. Now we have take suppose there are a project that is like LED blink. Okay. So you go to your core and take the source file from there. Suppose I have taken the LED dot or main.c. Okay, and paste it here, and you will take also the main.h file from inc.c and paste it also here. So if we see, this is a very big project, so let's try to do some simple. So there is a very simple code I have only written little bit. So first try to write execute this. Okay, so let's see what is written in this file. We have write a very less code in this file, just for understanding purpose we have write this code, that I have used a library file. Generally we use library header file like this, so I have used header file in this file also. And there is a standard library I have included, and there is a has defined file, that has defined function, macro function, that is. So inc, that's take the x argument and it will increment it by 1. Okay, then that is not needed right now. Okay, there is one variable, that is volatile global variable int counter, and I have called this macro function, and whatever the return of this macro function, that will store in this counter file, and then the infinite loop. Okay, in this way it will executing. So that is our main C file. Now we'll try to produce what from the C file to .i file. So let's see how we'll can do this. So first take one main C file where there is no dependency. Okay, that is the any other .h file or anything that can be create error. So that you have to keep in mind. So now go to your command prompt, open command prompt and locate to your file. So cd d drive, basic cd, okay, sorry. So you have to switch your d drive, then go to your file cd without. If you want to see that what are the available folder in this file, then you can like dir, then you will see that much of folder is available. So now you want to switch your, that file is seeing here. Okay, so you can write this here cd, then you have switched to that file. Now if you want to, what you have to do basically, you have to write your command. What command you have to write for compiling the .c file into. Now you can also see the dir here, that dots in my main.c is seeing or not. So you can see that there is 3 file available, that is age clock, main.c and save for future. These 3 file are available, but I want to take this main.c file and want to execute it. So write the command like rnan eabi gcc, then you write the you have to also tell that the which cortex you are using. So MCPU, microcontroller CPU equals to, right, cortex M4. Okay, then you can, that the instruction whatever you want to produce, that is arm mode or thumb mode. So generally we use is thumb mode. Okay, then for executing I file, you have to write -e, then put your main.c file, then what name you want to give, that you have to write the output file main.i. Okay, what is argument are not just missing argument to march, where it is march MCPU target cortex mm, cortex M4 is sorry, cortex M4, cortex hyphen M4. Okay, M thumb, that will be M thumb. So Armnan AVI MCPU is equal to cortex hyphen M4, then M thumb, then E, then it will be the input file, then the arrow, then output. Or you can also write like this also if you are compatible with this, hyphen O, then it will also produce the same output. First delete it, then we see that it is also producing the output file or not. Enter, then you also see that the main IO file also created. So see that the main.i, from the main.c you have produced main.i. So let's see what is present in this main.c. First go to the step on, and if you see that the uh, tasks of this preprocessor, so from main.c to producing main.i, which came into this picture, preprocessor. तो preprocessor यहाँ पे करता है क्या है, what actually done by this preprocessor actually expanding the include header file. Okay, so जो भी included header file I have added in this .c file, that's header file expanded. That means whatever written in this included file, what is actually needed for this code to execute, that's all the file included in our main I file. Then it's also expand the hash defined macro. If you see that we have written the macro file, and this macro file I have used in our main code also, so that actually expanded, it will be using the actual value and replace it. That's, and if you perform any conditional compilation, that is if and if or if def, this type of thing if we use, then that is also, if there is any else part that is not actually executing, that will omit or uh, keep everything done by this if def, and remove the comment, जो भी comment आपने added किया during the writing your C code, you have added some comment, that comment will also remove by this preprocessor in main.i file. तो रिजल्ट आउटपुट क्या आएगा, लार्ज expanded source before actual code compilation. So एक्चुअल कोड कंपाइलेशन से पहले इसको क्या दिखेगा, एक लार्ज सोर्स फाइल दिखेगा. ओके, so here if you see that suppose there is this before like this, after I file what will happen, wall header file fully expanded textually it is macro replaced by inline function, कंडीशनल रिजॉल्व हो जाएगा. इफेक्ट क्या आ जाएगा इसमें, इफेक्ट क्या होगा इसका करस्पॉन्डिंग, द कंपाइलर नाउ सी द प्योर सी फाइल विदाउट प्री प्रोसेसिंग डायरेक्टिव. कोई प्री प्रोसेसिंग डायरेक्टिव इसमें नहीं रहेगा. प्री प्रोसेसिंग डायरेक्टिव इस तरह की जो चीज़ें है उसमें उसको प्री प्रोसेसिंग डायरेक्टिव बोलते हैं हम लोग. बट इट विल नॉट सी इन योर मेन आई फाइल, इट विल सी ऑल द एक्सपेंडेड फाइल, इट विल रिप्लेस ऑल द प्री प्रोसेसिंग फाइल. So let's see. So there is no header file or dot has defined file, if you see that. So whatever the dot standard file dot std include dot std file, that wall file included in this dot I file. यहाँ पे जो स्टैंडर्ड आयो स्टैंडर्ड इनिट में जो भी डिफाइन किया हुआ था सब इन्होंने क्या किया, इंक्लूड कर लिया, पूरा इंक्लूड कर लिया इन्होंने. और हम लोग कोड कहाँ है, बस ये कोड है. तो इसको कोड में जो करना था उन्होंने कर दिया. देखिए यहाँ पे हैश डिफाइन के अंदर जो हम लोग वैल्यू लिखे थे बस उसको एज इट इज लिख दिया. ओके, तो हम लोग INC लिखे थे, कोड में अगर जाएंगे देखेंगे यहाँ पे लिखा हुआ INC5. उन्होंने क्या किया, इसको यहाँ पे रिप्लेस कर दिया. गॉट इट. ये क्या किया, INC5 की जगह हैश डिफाइन में जो था उसको वहाँ पे मैक्रो फंक्शन को यहाँ पे इनलाइन में इसी लाइन पे लाके छोड़ दिया. सो दैट इज आवर डॉट आई फाइल. सो यहाँ पे देखिए पहले मेन को स्टार्ट करना शुरू किया था लाइन पे, फिर बिल्ट इन है, उसके बाद फिर कमांड को प्रोसेस करने की कमांड लाइन का थ्रू एक्चुअली मैंने ये आर्गूमेंट दे रहा था, तो कमांड लाइन इसीलिए कमांड लाइन आया. फिर उन्होंने मेन को प्रोसेस करने की शुरू किया था, फिर उन्होंने देखा मेन में मेरा एक्चुअल फाइल में उसको ये फंक्शन दिखा, इस फंक्शन को उन्होंने प्रोसेस करके एज इट इज रख दिया, ये सब पूरा को हटा दिया इन्होंने. ओके, देन इन्होंने क्या किया, इसको ये लाइन मिला, देन इन्होंने पूरा स्टैंडर्ड लाइब्रेरी में जो था उसको एक एक करके इंक्लूड करना शुरू कर दिया. तो यहाँ तक उन्होंने उस स्टैंडर्ड लाइब्रेरी में व्हाटएवर मेंशन इन दिस स्टैंडर्ड लाइब्रेरी दैट विल copy and paste, simple like that, you can say like this. So after that ये पूरा आपका दिख रहा है till the end of this standard header file. Again it's start main.c. Then what you see that the main.c actually start in 11th line. So if you see here, that is also the 11th line. 11th में इसको फिर से क्या मिला, पहले लाइन पे वोलेटाइल काउंटर मिला. ओके, तो दैट इज द लाइन नंबर 11th. ओके, 11th column on. So this line is 11th line. ln 11 in the right corner if you want to see. ओके, सो फिर से इन्होंने 11 नंबर में लाइन पे. तो ये लाइन नंबर क्यों आता है, लाइन नंबर इसलिए ज़रूरत पड़ता है जो हम लोग जब कोई एरर आता है तो वी आल्सो ट्राई टू टेल दैट दिस लाइन दिस फाइल, तो अंडरस्कोर लाइन अंडरस्कोर फाइल इसका थ्रू क्या करते हैं, कौन सा लाइन में एरर है, कौन सा फाइल में एरर है, उसका इंफॉर्मेशन कंपाइलर देता है, तो इसीलिए लाइन की ज़रूरत पड़ता है। ओके, तो आज के लिए इतना ही, फिर हम लोग बात करेंगे आगे का प्रोसेस में कि कैसे .आई फाइल को लेकर फिर एस फाइल बनाया जाता है दूसरा, उसके बारे में फिर बात करेंगे। थैंक यू। अगर अभी तक कोई भी डाउट है आपको तो मेरे को मैसेज कर सकते हैं।